Hi, hello. All right, I'm trying to fix this camera real quick. Let me see what we got. I'm in a different room, but it'll work, right? All right, so hey, what's up? How you doing? Real quick, probably not real quick, but try to do a little quick video on function, operation, and composition. All right. Function, operation, and composition. So function, operation, and composition, what are the operations when you're dealing with functions? And what are they composed of? Stuff like that. So of course, I'm presuming you are very well aware of what a function is. You know that x cannot repeat. You know that y depends on x. Yes, you can have the same y. No, you cannot have the same x when you're identifying functions. I know you've probably already done the vertical line test as far as graphing, right? So that means if you can draw a vertical line and you have x value in two spots, like you have your graph, and if you have a sideways parabola, if this is your parabola, then, and your vertical line goes right here, this is your x value. And you see x gave this y output and this y output, right? So if that's the case, that's not a function, right? So we already did all that, and now we're on operations. So let me give you the list, the rules. And the cool thing about these operations is you'll notice as you advance in math, like when you're dealing with addition, okay? If you're doing f, let me see, okay, yeah, plus g of x, right? Let me put my x over here in parentheses. So my point is you're adding. When you're adding right here, it's going to turn into f of x plus g of x. Okay, so that's the rule. If you're adding your functions, and I know a lot of you wonder, well, aren't I supposed to distribute this x? Because if you distribute it, it would be the same thing, wouldn't it? So if that's how you understand it most at the beginning, then always follow the rule. Rules never change. F of x minus, g of x. Right? So far so good. And then so when it comes, let's see, fg, how do they write that? It's like, how do they write the multiplication? Oh yeah. Of x is of course going to be f of x times, and I like my little dot, g of x. Okay? And then the quotient rule. So this is your addition and subtraction rule. And basically, you are going to add the functions or subtract the functions as given. Okay? Just like it says. If you're multiplying, you're going to multiply. And then for dividing the functions of x, that does mean f of x divided by g of x. So again, when you see that notation, you guys remember, like, rules don't change. If you were to distribute this x to each of the terms, it would remind you of how the operations work. And of course, this is valid as long as g of x is not equal to 0. That's important because when we have it set up like this quotient, remember quotient is the answer to division. So if you see quotient, then you should know, oh, I was dividing. If you're dividing, anything divided by 0 is what? 0. And as you know, by this time, you've already been graphing, so you know you can't have 0 in the denominator if you have a fraction because that makes it undefined. So either reason that you can remember, we know we can't ever have 0 in the denominator of our fraction, right? So let's see some of this in action, okay? We're going to say that f of x Oh, that's my tired purple. I forgot to change it. Is equal to x squared plus 1. Y'all know me and my ones. And then we're going to say g of x. Oh, purple's dying. I guess you got to go buy purple. I'm so sad. I'm going to miss you. Just so you know, that's my favorite color. Okay. G of x is equal to 3x plus 5, right? So f of x is x squared plus 1, in case you can't see that. All right. So let's just follow through and see what each operation is. So we're going to give the parameters that we're going to add. A is that the same one? It is. I meant to switch colors, my bad. Hold on, gotta check teams. Okay. All right. Let's say the parameters for this, for A, it says that we are going to f plus g of 1. So what does that mean? That means that we're going to find f of 1 and find g of 1 and add those values together. Okay? And just remember, like I said, if you followed your order of operations, you would distribute. That would be 1 times f times g, right? You would be finding f of 1. And hold on, don't mistake. Let me be clear about what I'm saying. It would say f of 1 plus g of 1. And you remember way back when you first started functions that if you had something that said x plus 3 and it was given that, how did they give it to you? F of 2. So then you know that you would replace x with the 2 plus 3, and then so f of 2 would equal to 5. So go back to when you're thinking about this, if 2 is replacing x, this goes way back to, again, when you first started functions, and you know that y depends on x. So this is technically an ordered pair, right? Technically it is. If you didn't know, now you know. This is technically an ordered pair. Whatever you plugged in for x, the value you get out for y. That's what you're doing. It's just, now you're notating it a little bit differently, right? So, come over here. What is f of 1? So that means we're going to put, where we have x squared plus 1, we're going to put 1 in, plus 1. What's 1 squared? That makes 2. Okay? Then we're going to take our g of x, which is 3x plus 5, and we're going to put in 1. And 3 times 1 is 3. 3 plus 5 is 8. And it says that we're adding our two functions. Right? So, f plus g of 1 is equal to 10. Is that a little clearer? Does that help a little bit more? It's equal to 10. And then, so let's see if I can find a multiplication one, because you know the subtraction is the same as the addition. So you would do the same thing if it was a subtraction. So let's plug it in. Let's see what it looks like with multiplication. Okay? So if we're doing multiplication, what time is it? Okay. I forgot to start my timer again, you guys. So, I'm trying to keep my eye on the clock. Let's take f of g of 5, right? And so we remember that means f of 5 times g of 5. So far, so good. And of course, we're still using, excuse this little rowdy, so you hear some little rowdy students in a study room behind me. They forget that they're supposedly adults now. You know, it happens, I guess. We still have f of x is equal to, what did I say it was? X squared plus 1. And we have g of x is equal to, what was it, 3x plus 5? Yes. 3x plus 5. All right. So, again, we're going to substitute in where we do our f of x. So we'll have 5 squared plus 1. 5 squared is 25 plus 1, that gives us 26, right? And then for g of x, we'll have 3 times 5 plus 5. Oop, I don't know why I wrote 12 and it's 15. Don't even ask me. 15 plus 5, which is 20, right? And then what do we do next? Yes, 26 times 20. And so I'm going to cheat. It's not cheating, but I'm going to do my quick math. Because I know anything times 0 is just going to bring down the 0, right? So 26 times 2, what's that? 52. And then I'm going to bring down that 0. So my answer is 520. So that covers the basics. Do y'all want to see the division as well? Let's see if I can get some division on there for you. See if I can find a one that divides. Let's see what we got here. Okay. Let's go with, let me leave my functions up there. So this one is going to be, what do we got? Ooh, f of g of 0. So what does that mean? F of 0 divided by g of 0. So f of 0 is going to be 0 squared plus 1. 0 plus 1 gives us 1. That's a 1. I know it gets sloppy when I start writing like that. And then we have 3 times 0 plus 5. 0 plus 5. We have 5. So f of 1 is 1. F of 0 is 1. G of 0 is 5. So we have 1 divided by 5. And just like that, right? We just do what it says. So y'all are like, oh, I know how to do that. I know how to do that. Give me a good one, right? Give me a good one. Okay. I'm going to change your values a little bit. Let me show you how rules don't change. And you just have to know the rule for the form that your value's in. So we're going to erase this. I think I can keep with the same functions. Let me see. No, let me change your functions. So I'm going to change your functions to f of x is going to be 8x minus 9. And g of x is going to be, you ready for this? The square root of 2x minus 1. Oh, yeah, that works. Nothing is different. Nothing is different. Okay? Yep. All right. And it doesn't give us, I'm like, does it give us anything? No, it just wants us to find. So A says we are going to find f plus g of x, right? So what does that mean? F of x plus g of x, right? Well, are these like terms? Did it tell us to solve? We always simplify, but it didn't tell us to solve. So we don't have to worry about trying to solve or getting x from underneath that radical. We don't have to combine like, well, you always combine like terms, but we don't have to solve. We're simply going to write f of x plus g of x. F of x is 8x minus 9 plus the square root of 2x minus 1. That's it. They're not like terms. We can't combine anything. We don't have to take it out of the radical. So that's just what it is. We did exactly what it said. F of x plus g of x. And that's what we did. Yeah. Okay. Subtraction is going to be the same thing. You know that. Multiplying is going to be the same thing. When we multiply, what are we going to have? We're just going to have 8x minus 9 times the square root 2x minus 1. And again, we can't multiply that right now because this one's under the radical and this is just a regular binomial. So if it says fg times x and these are your functions, that's what it looks like. All right? So here, let me show you. This is fg of x. That's this one. And so what's f over g of x going to look like? You tell me. You tell me. Yes. We got, what is it? 8x minus 9 over the square root 2x minus 1. So I want you to know, right now, you can leave this answer, depending on who your instructor is. But fractions are called rational expressions. We've talked about this. And you cannot leave a radical in the denominator. But for now, since it didn't tell you to evaluate or tell you to give the value of anything, it just wanted you to complete that or show what that operation was going to look like. Let me read the directions. Yeah, it just said, yeah, it didn't tell us to do anything. So that's where you would leave it. If it just says, find each of the following. Yeah. And we're not going to give the domain. That's going to be a whole nother lesson about the domain. The domain just means how much of the x-axis does your function cover. But we'll talk about that another time. I just wanted to focus on showing you some operations, what it looks like. Here we go. Let's try something else. I don't know what's my timing at, you all? Is it close? I can't believe I forgot to start the timer. Let's see if I got time to do one. Let me try to find a good one. And then we'll move on to the difference quotient. I'll do that next time. Yeah? Sound like a plan? Okay. So for now, let's see. I'm trying to find some good. Okay, here's one. F of x is equal to 2x plus 1, and g of x is equal to square root of x. All right. And so, let's do f plus g of, what did it say? 4. So what does that mean? So you see what I do, right? I write this down where I know it's where I can look at it and reference it each time. So when I start this, I'm gonna be like, all right, what's my rule? And I look over here and I see my rule. I'm not questioning it. It says if I'm adding or subtracting, this is what it looks like. It says if I'm multiplying, this is what it looks like. If I'm dividing, this is what it looks like. Point blank. That's what I do. So that means I have to find f of 4 and add it to whatever g of 4 is. F of 4, 2 times 4 plus 1, 8 plus 1, 9. G of 4. Then we got square root of 4, right? Which is 2. 9 plus 2. Bam. Just like that. Let me see if I... Ooh. Oh, this would be cool. Let's just say it was minus. Let's say you had minus. Let's do f minus g of 4. Right? Is that going to make it do what I want it to do? I don't think that's going to make it do. Oh, that's because I didn't want 4. I saw it. Here it is. F of g. I was trying to make it so you would have a negative value underneath the radical. So f of negative 2 says 2 times negative 2 plus 1, negative 4 plus 1, negative 3, right? And then g of negative 2 says the square root of negative 2. Now, you come up to that, it's undefined. We don't have that answer, right? So what would you do? Have y'all already done I? That would be the actual technical answer. If you haven't done I, then you would just say this is undefined. Okay? And let me see. I don't really think, man. Let me try to find you some. There we go. Let me do one composite for you. All right, that's just basic. Now, when we talk about composite, that means you're putting one function inside the other, right? Because you're given two functions usually. One's called f, one's called g. It doesn't matter if it's fg, mn, qp, ts, it doesn't matter, but one is being put inside the other, right? So when we talk about that, do rules change? No, I told you this. Rules don't change. If f and g are functions, then the composite function or composition of g and f is defined by... You're like, what is all that word? I don't know. I don't know what those words are. That's not a multiplication. It's a circle. I always call it golf. And so this notation, I know that for me personally, I thought it was kind of confusing about why they did it like that. I mean, it makes a little bit more sense now that I've gone a little bit further into math, but still. I just knew this times this, you know what I'm saying? We put this and this and put that into here. So the one that's closest to the x, you put whatever's in here in this one first. And then you take that answer and put it in here. That's what I know. Okay? So hopefully I don't run out of time for this. Let's see. We got f of x is equal to 2x minus 1, and g of x is equal to, 4 over, you like that, don't you? X minus 1. All right, so we are going to find, here we go. We're going to find f of g of 2. Hold on one second. So sorry, hold on.